Electrical current is the flow of charge. And most of the time, the charge that we're talking about is electrons. So current is just electrons that move. So in order to transfer energy via an electrical pathway, all we need to do is move some electrons. We can make the electrons move in two different ways. The first is probably what we all imagine when we think about electrons moving through a circuit. The electrons are all going in the same direction, they're all going continuously flowing around and around in one direction like water flowing through a pipe. And this is called direct current. And this is the kind of current that you'd get out of something like a battery, for example. But we can also transfer energy around a circuit without the electrons themselves actually going all the way around the circuit. What we can do is make all of the electrons move and then make all of the electrons move back in the opposite direction, and then make all of the electrons go back again in the first direction, and again and again, and so on and so on. We still have a movement of charge all the way around the circuit, so we still have a current. And this is called alternating current because the electrons are continuously alternating or changing their direction. And this is the type of current that we get delivered to our homes from the national grid. This so-called mains supply, all of the plug sockets around your house are delivering an alternating current. And in fact, this one in particular has a frequency of 50 Hertz, which means that the electrons are switching direction 50 times per second. We sometimes refer to it as alternating potential because that's how we get the electrons to swap directions constantly. We switch the polarity of the potential difference between positive and negative 50 times per second, making those electrons move back and forth. Anyway, there's a lot more to be said about current, but I think we'll leave it there for now.